Class 7 Maths, Chapter 1, Integers. Introduction to Exercise 1.1. So first of all, let us see what are the types of numbers in maths. According to the properties and how they are represented in the number line, the numbers are classified into different types. For example, natural numbers, whole numbers, integers, rational and irrational numbers. So one by one we will see what are these numbers. So coming to natural numbers. What are natural numbers? You have learned natural numbers in class 6. Natural numbers are also called counting numbers, which contains the set of positive integers. Note this point, positive integers. We'll come to know what are these positive integers later. So the natural numbers are counting numbers which start from 1 and end at infinity. So all positive numbers starting from 1 are called natural numbers. Examples are 10, 89, 1130, etc. What are whole numbers? Whole numbers are also known as natural numbers with 0. The set contains of non-negative integers, which it does not contain any decimal or fractional part. So, what are natural numbers? Natural numbers are numbers from 1 to infinity. Okay. If we add 0 to the natural numbers, see, natural numbers with 0, these are called whole numbers. Whole numbers are denoted by W. So, natural numbers plus 0 are called whole numbers. Examples are 10, 89, 1130, 0, 499, etc. All these comes under whole numbers. So, what are these non-negative integers? We will see now. What are integers? Integers are defined as the set of all whole numbers with a negative set of natural numbers. See, these are set of all whole numbers. What are whole numbers? Numbers from 0 to infinity are called whole numbers with a negative set of natural numbers. Natural numbers are 1, 2, 3, 4, 5, etc. So, negative set of natural numbers is minus 1, minus 2, minus 3, minus 4, minus 5 till minus infinity. Thus, negative set of natural numbers plus whole numbers are called integers. Thus, integers are minus infinity to plus infinity, which you can count. To be crisp, 1 to infinity, these are natural numbers. 0 to infinity, these are called whole numbers. And minus infinity to plus infinity, these are called integers. Thus, examples are minus 151, minus 2, 0, 1, 46, 872. These are natural numbers, these are whole numbers, and these are integers. Addition and subtraction of integers. Two integers A and B. The rules for addition are, if one integer is having plus sign and other integer is also having plus sign, then you should do addition and put plus sign before it. For example, let us take A as 4 plus B as 5. Answer is 4 plus 5. You should do addition, 9. You should put this sign plus. Similarly, if you take two integers A and B with minus signs, the rule for addition is, for example, you take minus 4 plus minus 5. So what you should do is, you should add it. 4 plus 5 is 9, but you should put the sign as minus before the result. So in case of two integers with different signs, you should do subtraction. For example, 4 plus minus 5. So this becomes 4 minus 5. This is equal to 1. And the sign, you should put the sign which the larger number contains. So here 5 is the larger number and its sign is minus. So you should put minus sign. We'll see other example. Let a be 5 and you do addition with minus 4. So you will get answer as 5 minus 4. That is equal to 1. And the sign you put is plus because 5 is the largest number and 5 contains plus sign. Similarly, two integers with minus and plus sign are added, then you should do subtraction. For example, minus 4 plus 5, which is equal to minus 4 plus 5, that is equal to 1. And the sign you should put is plus because larger number is 5 and 5 is having plus sign. Similarly, if you take a as minus 5 plus 4, this becomes minus 5 plus 4 and the solution is 1 and the sign is minus because the larger number 5 contains minus sign. Hope you understand the rules for addition and subtraction of integers. Properties of addition and subtraction of integers. First property, closure property under addition. In class 6, we have learned that sum of two whole numbers is again a whole number. For example, 17 plus 24 is equal to 41. 17 is a whole number, 24 is a whole number, and the sum 41 is a whole number. Hence, whole numbers addition follow closure property. Similarly, and now let us see if the sum and difference of integers follow closure property or not. Closure property under addition. 17 is an integer, 23 is an integer, sum is 40, which is also an integer. Minus 10 is an integer, plus 3 is also integer. Solution is since one sign is minus and other sign is plus, we should do subtraction. The answer is 7. And since 10 is the larger number with minus sign becomes minus. So this is also an integer. So result is an integer. Similarly, minus 75 plus 18. This is equal to 57. So 75 is having minus sign. So the result will have minus sign. So this is also an integer. 19 plus minus 25 is equal to minus 6. Result is an integer. 27 plus of minus 27 is equal to 27 minus 27, which is equal to 0. 0 is also an integer. Minus 20 plus 0 is minus 20, which is also integer. Minus 35 plus of minus 10 is equal to minus 35 minus 10. So here, since both are minus signs, we should do addition, which is equal to 35 plus 10 is equal to 45. And since both are having negative signs, we should put negative sign. So minus 45 is also an integer. So addition of all the integers is an integer. So integers follow closure property under addition. Now let us see whether integers follow closure property under subtraction. 7 minus 9 is equal to minus 2. Result is an integer. 17 minus of is, this is equal to 17. Minus of minus will become plus. So 17 plus 21 is equal to 39. This is equal to integer. Minus 8 minus of minus 14 is minus 8 plus 14, which is equal to 6. This is also an integer. Minus 21 minus of minus 10. This is minus 21 plus 10, which is equal to minus 11. This is also an integer. 32 minus of minus 17 is 32 plus 17, which is equal to 49. This is also an integer. Similarly, minus 18 minus of minus 18 is plus 18, which is equal to 0. This is integer. Minus 29 minus 0 is equal to minus 29, which is also an integer. Thus, closure property under subtraction is also followed by integers. Now let us see if integers follow commutative property. So first we'll see for addition whether integers follow commutative property or not. In order to verify whether integers follow commutative property formula, that is a plus b is equal to b plus a. We have studied in class 6 that whole numbers like 3 plus 5 is equal to 5 plus 3, which is equal to 8, can be added in any order and they follow commutative property. Similarly, for integers, now we'll see whether they follow this commutative property as a plus b is equal to b plus a. So we have 5 plus minus 6. These both are integers. So 5 plus minus 6 is, since both are having different signs, we should subtract it. So 5 minus 6 is 1, and since 6 is the larger number, we put minus sign. So solution is minus 1. And similarly, this is a, this is b. Now minus 6 is b and 5 is a. B plus c is minus 6 plus 5, which is equal to minus 1. So a plus b is equal to b plus a. Similarly, if you see minus 8 plus minus 19 is minus 17 and minus 9 plus minus 18 is equal to minus 17. This also follow commutative property. And minus 23 plus 32 is equal to 9. Similarly, 32 plus of minus 23 is 32 minus 23, which is equal to 9. So this also follow commutative property. Similarly, minus 45 plus 0 is minus 45 and 0 plus minus 45 is minus 45. Hence, all integers for addition, they follow commutative property. Now we'll see whether they follow commutative property for subtraction or not. For subtraction, in order to follow commutative property, integers should follow a minus b is equal to b minus a. For whole numbers, we know that subtraction is not commutative property. Now for integers, we'll see whether this is applied or not. So let us take 5 and minus 3. So 5 minus of minus 3 becomes 5 plus 3. See, 5 minus of minus 3 becomes 5 plus 3, which is equal to 8. And similarly, this is a and this is b. So if we take b minus a, that will become minus 3 minus 5. That is equal to minus 3 minus 5, which is equal to minus 8. So 8 is not equal to minus 8. So a minus b is not equal to b minus a. Hence, for subtraction, integers does not follow commutative property. Associative property. What is associative property? For any integers, if they follow this formula like a plus b plus c is equal to a plus b plus c, then those integers follow associative property. Consider these integers minus 3, minus 2 and minus 5. Let this be a plus b plus c. This becomes minus 5 plus minus 3 plus of minus 2 is minus 5. Minus 5 is minus 10. Similarly, minus 5 plus of minus 3 is minus 8. Plus of minus 2 is minus 2. This is equal to minus 10. So a plus b plus c is equal to a plus b plus c. So these integers follow associative property. Similarly, we will see whether minus 3, 1 and minus 7 also follow the same property and confirm if three integers follow associative property or not. Let minus 3 be a, 1 be b and minus 7 be c. So this is a plus b plus c and minus 3 plus 1 be a plus b plus minus 7 be c. Okay. Now minus 3 plus 1 plus of minus 7 is equal to minus 3 plus 1 plus of minus 7 is 1 minus 7. This is minus 3 plus 1 minus 7 is minus 6. This is equal to minus 3 minus 6. The solution is minus 9. So here minus 3 plus 1 is minus 2 plus minus 7. This is equal to minus 2 minus 7. This is equal to minus 9. So in both cases, we get solution as minus 9. Is minus 3 plus 1 plus of minus 7 same as minus 3 plus 1 plus of minus 7? Answer is yes. So integers follow associative property. Next, additive identity. Additive identity is a number. If we add to any number, the result should be the same number. For example, for a whole number, if we add 0, we get the same whole number. For example, 1 is whole number. If we add 0, we get answer as 1. 0 is whole number. If we add 0, we get answer as 0. 20 is whole number. If we add 0, we get answer as 20. So 0 here is an additive identity for which if we add to a whole number, the answer will be the same whole number. Similarly, we'll see if integers is having any additive identity. Now, minus 8 plus 0 is minus 8. 0 plus minus 8 is minus 8. Minus 23 plus 0 is minus 23. 0 plus minus 37 is minus 37. In all the cases, we get same integer when we add 0. Hence, the above example show that 0 is an additive identity for integers. Thus, in general, we can say a plus 0 is equal to a, which is equal to 0 plus a. Now, let us try these problems. Write a pair of integers whose sum gives a negative integer. So, we should write any two integers whose sum gives a negative integer. From the rule of addition of integers, we learned that if two numbers are having negative sign, then the sum of those numbers will also have a negative sign. So for example, take two numbers 4 and 6. So if we add this becomes 10. But if these numbers are negative numbers, minus 4 and minus 6, negative integers, this becomes minus 10. Similarly, you can take any other two negative numbers like minus 2 plus minus 4, which is equal to minus 6, and minus 100 plus minus 90, which is equal to minus 190. Thus, these are pair of integers. Like this, you can write n number of integers. Dear students, if you could think any such integers, please comment down two numbers whose sum gives a negative integer. Now write a pair of integers whose sum gives 0. Same number with different signs, if we add, we get 0. For example, 1 plus minus 1 is equal to 0. 10 plus minus 10 is equal to 0. 99 plus minus 99 is equal to 0. So these are the pair of integers whose sum gives 0. Please comment if any two numbers if you could imagine. So write a pair of integers whose sum gives an integer smaller than both the integers. You should write pair of integers when you add, the sum should be also an integer smaller than both the integers. In this case, you can write two negative numbers like for example minus 4 and minus 8. If you add them, we get minus 12. This minus 12 is smaller than minus 4 and minus 8. Similarly, minus 6 and minus 12. Answer is minus 18. So, two negative numbers, sum will be negative number which is smaller than the numbers which we add. Now, write a pair of integers whose sum gives an integer smaller than only one of the integers. In this case, you take a positive number and a negative number. For example, if you take number 8 and other number minus 2, if we add, you get 6. So this number is less than only one number 8 and greater than minus 2. If you take in reverse like 2 as positive number and 8 as negative number, the solution you get is minus 6. So this is also smaller than 2 and greater than minus 8. Thus, these are also pair of integers whose sum is an integer smaller than only one of the integers. Now, pair of integer whose sum gives an integer greater than both the integers. If you take integers with both plus signs, so 6 plus 4, that is equal to 10. So 10 is greater than both the integers. 10 plus 9, 19. 21 plus 31, 52. Thus, any two positive integers are the pair of integers whose sum will be greater than both the integers. Now, write a pair of integers whose difference gives a negative integer. Take any two numbers. Let us take 4 and 6. So, the difference minus is equal to minus 2. Similarly, 6 minus 9, that is equal to minus 3. You also can take integers like minus 3 and 8. If you perform subtraction, you get minus 11. Thus, these are the pair of integers and you can write n number of integers, and if you could think of any such kind of integers, please put your answer in the comment section. Now write pair of integers whose difference gives 0. A pair of integers whose difference gives 0 are the integers with same value. For example, take 4 and 4. If you subtract, you get 0. Minus 10 minus 10. This is equal to minus 10 plus 10, which is equal to 0. 100 minus 100 is equal to 0. So, two integers with same value, and if you subtract each, you will get 0. Now, write a pair of integers whose difference gives an integer smaller than both the integers. Take any two positive integers. Let us take 8 and 5. And if you subtract, you get 8 minus 5, which is equal to 3. 3 is lesser than 5 and 3 is lesser than 8. So these are pair of integers whose difference gives an integer smaller than both integers. Similarly, take 10 minus 20. So answer is minus 10. So minus 10 is less than 20 and also less than 10. Now we'll see a pair of integers whose difference is an integer greater than only one of the integers. Let us take 20 and 8. If you subtract 20 and 8, you get 12. 12 is less than 20 and greater than 8. So 20 and 8 are the pair of integers whose difference is an integer greater than only one of the integer. Similarly, you take 15 and 4. 15 minus 4 is equal to 11. So 11 is smaller than 15 but greater than 4. Similarly, you take minus 10 and minus 4. If you subtract, you get minus 10 minus minus 4, which is minus 10 plus 4, which is equal to minus 6. So minus 6 is greater than minus 10 and less than minus 4. Thus, minus 10 and minus 4 are also pair of integers whose difference is greater than only one of the integers. Now we'll see pair of integers whose difference gives an integer greater than both the integers. Let us take 10 and minus 6. The difference is 10 minus of minus 6, which is equal to 10 plus 6, that is equal to 16. So 16 is greater than 10 and also greater than minus 6. Similarly, take 20 and minus 10. So the difference is 20 minus of minus 10, which is equal to 20 plus 10, that is equal to 30, which is greater than 20 and also minus 10. So like this, you can write n number of integers whose difference gives an integer which will be greater than both the integers. Example. This example is taken from NCERT book. Write down a pair of integers whose sum is minus 3. Sum of two numbers should be equal to minus 3. Let us take any integer, let it be 4. So 4 plus minus 7 will be minus 3. So 4 and minus 7 are the integers whose sum is equal to minus. Similarly, you can take any number, like let us take 8 plus dash is minus 3. So minus 11. So 8 and minus 11 are also integers. Similarly, write down pair of integers whose difference is minus 5. So difference of two numbers should be equal to minus 5. Let one number be 10, other number will be 15. So 10 and 15 are the two integers whose difference is minus 5. Similarly, let us take one more pair of numbers whose difference is minus 5. Let this be minus 5. Minus 5 minus of 0 is equal to minus 5. So minus 5 and 0 are also the pair of integers whose difference is minus 5. So write down pair of integers whose difference is 2. So pair of integers whose difference is 2. So if you take 5, 5 minus 3 is equal to 2. So 5 and 3 are integers. Similarly, if you take minus 2 and minus of minus 4, this will become 2. See, minus 2 minus of minus 4 is plus 4. This is equal to 2. And minus 2 and minus 4 are the two integers whose difference become 2. Write down a pair of integers whose sum is 0. Sum should be 0. If you write 5, 5 plus of minus 5 is equal to 0. 5 and minus 5 are pair of integers. Similarly, you take minus 100 plus of dash equal to 0. This is nothing but minus 100. Similarly, 0 plus 0 is also equal to 0. If you could think of any numbers for these A, B, C, D problems, please write down in the comments.